Bystronic is a leading global supplier of system solutions for the sheet metal industry. We provide laser cutting systems, bending systems, automation, software solutions, and comprehensive services.
Sorry, I need a sip. Ah.
He's good, no?
Mummy.
Let's say he has a confident voice, yes.
Ma. Shall we? Client happy?
Client happy, but please get to the end of the line this time and add a little verve.
The verve is there. You may not be able to hear it right now, but you will in post-production.
In post, we are in...
We offer worldwide presence and competence. We speak your language and understand your needs. We are here for you.
Sorry, we are here for you. I mean, I hear the words, but I'm not getting anything from them, you know?
Could you please just say the lines?
May I?
Please.
It means that we offer much more than just a machine. We support our customers with flexible financing models, training, maintenance, a long-term spare parts service, phone hotlines and online support. And we also operate local sales and support offices in many, many countries.
Yes. Now you see, now it's...
Coming alive. We should be saying this.
It is more text, though, so we will have to renegotiate with my agent.
Can't you just record it and we'll look at it later?
Well, I'd love to, but my agent would kill me.
If only. Fine then, continue with the script.
Right you are. Where were we?
At customer service and post-sales services, would you believe?
Rolling.
We don't simply develop machines that cut or bend sheet metal. No, our customers need flexible systems for ever-changing order positions and batch sizes. Automation to achieve top productivity with integrated systems and the right software that cross-links everything. Bystronic stands for Swiss quality.
Sorry.
Really?
Swiss quality. I mean, it's a bit of a cliche, isn't it? And actually, while we're at it, your slogan, best choice, kind of sounds like we've just won the buzzword bingo.
Guys, if you want to sort this out, I'm just going to pop out for a smoke.
Let me explain. First of all, Swiss quality. Do you know the Bystar fibre? The Bytrans Cross or Bysoft? Have you ever seen them laser cutting and bending those sheets? It's like butter. Once you've seen it, you can't help but be excited. The beauty of a laser cut. The precision of a bent metal sheet, from very small to very large, but all with the precision of Swiss clockwork, perfectly formed and expertly fitted. Now, best choice. When you say yes to a partner, be it in business or private life, you make a commitment to the future. Bless you, Katie. Now, you're still young, but one day, you're going to want someone for the long run. Someone who shares your vision for the future. You see, at Bystronic, we think about tomorrow's sheet metal processing. We have some footage of that, right? In what we call the smart factory, variable orders will be produced automatically on flexible systems. A clear vision and state-of-the-art technology means cost and process optimization, which in turn means higher earnings. And who's behind this success? The employees of Bystronic worldwide. Now, you'll say that's just another cliche, but nobody else sets new standards like they do. With their enthusiasm, their ideas, and their know-how. Actually, I stand corrected, because our success is also due to our clients. It's their feedback that we use to develop new technologies. And until they are perfectly functioning, we will not launch them. And none of our employees will settle for less. Not in Asia, not in America, not in Europe, not in Switzerland, nowhere. And that's what we mean by best choice. I'm sorry, I think I interrupted you.
Did you record this?
Sorry, did he say something? I couldn't hear a word.
He says we're done.
Really? That looked like more words to me.
No, really, we're done. But you can stay here till 5 because it's in your contract.
Oh, no, I'm more than happy to do another version. We'll just reach my agent later on. That's no problem. Gentlemen? Hello?
Dear ladies and gentlemen, we warmly welcome you to the first Digital Technology Day of 2021. My name is Sebastian and I am happy to host this event for Bystronic today with my colleague Sarah.
Thank you, Sebastian, and also a warm welcome from my side. I'm so excited to show you guys our newest products in the field of cutting, bending, and automation. So be prepared for interesting topics, innovative machines, and also our new features.
But before we start with those great topics, let us introduce you our experts for today, Benedikt and Carsten. How are you?
We have a great show today together. We already started about 2 hours ago with the German colleagues with a late night show, and we have been welcomed our new laser. It's a 15 kilowatt laser P-Star fiber, and we will see much more about this laser soon. But before we do this, I would like to highlight one more point, and it's our landing page. You will find the link to this landing page also in the chat. So if you would like to see more afterwards, if you would like to have a live demonstration just for you with your individual parts, that's no problem. Just go on this link and you can register yourself for a live web demonstration. We have also a big, nice demo center in Australia. And of course, you can do a demonstration there as well. But if you would like to do a demonstration here in Germany, it's all no problem. We have all cameras set up, and we can do every day a live demonstration with you, especially for you with your parts as well. You can send your parts before, and then we can do this together with you. So with this, I hand over to my colleague, Benedikt.
Yeah, welcome also from my side. My name is Benedikt Kreisel. I'm the product manager for bending automation here at Bystronic. And we hope to show you today nice demonstrations of our product portfolio, bending, laser cutting, and also automation for sure. I want to give you a short hint because we want to have an interactive event with you, so you be part of this event today, and we want to invite you to go here on slido.com and sign in with the code 952, or just scan with your mobile device the QR code, the data matrix code you can see here, and then you can join the interactive event to vote with us. We have some questions prepared for you, and we want to have your opinion to our topics we present today. So please feel free to join here, slido.com. Type in 952, this is the event code to join in, or just scan this QR code. To have a short test at the beginning, we want to start with our first question, with our first poll. And the question is, which country do you come from? So please feel free to join, send us your answers, and then we can see if our vote is working. So we wait here a few more seconds that you have the possibility to join here, and then we can see if you have voted here. So the first vote is here, Australia. So we can see it is an Australian event for you for sure. You are from Australia.
Germany as well.
Also, someone from Germany has joined this event. Also nice to see. So you can see it's an international event. Also, South Korea is here. So welcome to you all over the world. And no more words needed in my opinion. And for this, I want to hand over to our colleagues down at our Bystar Fiber, to Sebastian and also Sarah.
Thanks to Carsten and Benedikt. So let's start very fast. Let's start with 15 kilowatt.
As you already can see behind us, our newest member of our demo center in Gotha, the new Bystar Fiber 15 kilowatt. Before you see our newest member in action, let's hand over to our software expert Benjamin, who show you Bysoft 7 cutting.
Hello, my name is Benjamin and I'm responsible for software sales in Germany. Almost every company nowadays has an ERP system. How do I get the production order data to the machine and to the customer within a very short time? I will now show you a short presentation. Imagine your sheet metal production as followed. For example, you have a laser system with automation, a small storage tower behind it, a clearing area, and a bending machine automated. The entire production order, from quotation to shipping and invoicing, is managed in your ERP system. You receive the parts from your construction or as 2D or 3D data from your customer. The NC program for your machine are generated in the production planning and programming department. At the beginning, the customer's production order is created in your ERP system. All other data is thus already generated in digital form. At the same time, CAD data are also designed or made available, and these must now be transferred to work preparation. Most of the time, it looks like this. This is a picture from our own work preparation before we worked with the Plant Manager module. Order papers are printed out and the programmers have to import these 2D or 3D data individually into the Bysoft 7 software. This is where the Plant Manager comes into play. The Plant Manager is a module of Bysoft 7 which combines the order between the ERP system and the production. By using an XML interface, all production order data and also the CAD data can be automatically transferred to Bysoft 7. This means that the parts list with article number and material quality, as well as the number of pieces and the end date, are linked with the correct CAD data and automatically imported into the Plant Manager. Repeated parts are recognized and new parts are automatically imported into the software using the Auto Parts module shown before. The Plant Manager can now use the entire order backlog of the ERP system for his planning. The software knows all laser and bending machines. It knows exactly how much capacity is available per machine, and it knows which material and which order can be produced on which machines. In addition, it knows the exact date when the components have to be cut and bent. Thus, all information is known to be automatically generated in order to plan perfect jobs for the individual machines. At this point in time, the required raw material can be reported back to the ERP system. This helps the purchasing department for planning. The jobs are now sent to the laser and the bending machine, which the operator already sees in the optimal order in the controls job list. The jobs are sent to the machine in such a way that setup and non-productive times are as short as possible. If the job has been cut or bent, the machine automatically reports the production data back to your ERP system. This gives you the perfect basis for an order recalculation. The machine reports back the actual material consumption, including the waste. You can thus trigger a raw material posting in the ERP system. The ERP system receives the affecting cutting and bending time, including waiting and stopping times, in order to book these on the order. The plant manager has the part removal model for quality control and for reporting rejects. A screen is made available to the operator in the clearing area, on which the cutting plan is displayed visually. He can thus quickly and easily sort the cutting plan on pallets based on orders or other criteria. With the plant manager, you can digitize the entire process flow and no longer have to manually book the individual process. Now we are going to have a look how the plant manager looks like. Let's assume my customer ordered the parts and I want to manufacture them. The plant manager runs as a service and is installed on your server. So he works 24 hours a day, 7 days a week. If a production order is now created in the ERP system, it can be imported automatically. In this view, I can now manage my orders. Open orders can be processed immediately. Incomplete ones require further information from the operator. My current orders are also clearly displayed. In my example, I have a Bystar and Bysmart fiber with different laser powers. There are also 2 bending machines, 1 expert per 250 tons and 1 expert per 320 tons, each in 4 meters. The software now automatically generates laser jobs for the machines. How does this work? I'll show you by using the job assistant. All parts to be manufactured are now sorted according to material quality. For example, I choose 1 millimeter stainless steel. The plant manager knows the available raw material sheets and also the residual sheets. These are selected automatically. Perfect nesting plans are now generated for the respective material and the respective machine. Residual sheets are automatically engraved and saved in the administration. All of these jobs are automatically scheduled in the calendar. The bending jobs are also generated with a job assistant. All bending programs are planned in the perfect order on the machine. You already know the module. It is the tool setup optimizer, which is executed automatically in the background and guarantees you an optimal bending sequence on the machine. Thus, all machines are perfectly programmed. To remove parts from the laser machine, the part removal module is available. In the part removal program, the cutting plan is shown in color according to the order number or according to individual adjustable categorization, such as the customer or a subsequent work step. With this information, your machine operator clears the cutted plan in the shortest possible time and sorts them onto the correct pallets with little effort. In addition, batch tracking and residual sheet management can be maintained via this module. You see, the Plant Manager is the optimal support for your process planning and your programming department. Orders can be sent from the ERP system to the machines in a paperless and process-reliable manner within a very short time. In this way, you not only optimize the interfaces, but also your entire production process. Please do not hesitate to contact us for an individual offer and presentation. Thank you very much and see you next time.
Thanks, Benjamin. You want more information about our Plant Manager? Feel free to book an online demo at any time. You will find the link for our landing page on our YouTube section in YouTube.
So we're going fast and precise with our new Bystronic Fiber 15 kilowatt laser cutting system with its features beam shaper, curve scan and nozzle control tool. So Eric, it's your turn.
Yeah, welcome. And yeah, in Germany we say good night, and in Australia, good morning. From my side, my name is Eric. I'm application technician in the demo center here in Gotha, and now I want to show you something about the laser system. So as my nice colleagues Sebastian and Sarah tell you before, it's a brand new machine. It's a Bystronic Fiber 15 kilowatt, which is our flagship machine and laser cutting system at the moment. You can have this machine from 150 by 3 meter cutting size up to 12 meter by 2 meter and 50, and you can have this machine in standard range of power from 2 kilowatt up to 15 kilowatt. And in our case here in the demo center, we are now having a 15 kilowatt laser system, which is our newest, biggest laser source, and so we can cut also really big parts. With this machine, really thick parts are up to 50 millimeters. Today we will show you a little bit thinner ones, so 30 millimeter, but this is also a big deal for most of the laser machines on the market. Maybe some words more to the machine. It's a 3015 and it's equipped with our beam shaper, which is our tool for making really high quality cuts. For thick material, we have the curve scan attached, which is an automatic detecting of the cutting gap, which means the laser will automatically check the cutting gap and check if the cutting result is really good. And it's really important when you have like automated laser systems. We have the NTC, which is an automatic nozzle centering tool, what also can control the nozzle, which also can center the nozzle for the first time. And second one is it can look for the quality of the nozzle to make sure that you have a clean cutting result. What we have also here, we have a detection eye. We have an automatic nozzle changer with 64 seats to give you most flexibility during the cutting process. Yes, and I don't want to talk not so much about the laser system. I want to say, yeah, start the fire, and then we will go with the laser cutting. Okay, so as I talked, it's 30mm mild steel. So it's various range in the machine, different tooling set up to the other machines. This machine is also equipped with high speed oxygen parameters for speed cut, with also oxygen, not with nitrogen anymore, and only so we can be nearly the same speed in oxygen cut than in nitrogen cut, and also with thick material up to 50mm. So we have a second joint in with the machine, so we cut, and we have some holes in it. So the joint in will take some small segments to come through, push through the whole material during this process. And second hole done now. The control is every time the easiest and the same one that Bystronic has with all machines, like the bending machine you will see later on. So we have an easy control in the cutting parameters, also in our bending parameters or bending control. So we are really simple with that. And yeah, maybe some words about the part we cut now, and maybe about the parts we cut through the whole time. These parts are for our newest product in the bending technology. It calls by Benstar. It's a new flagship product in bending, in small bending length. And for this, my colleagues Carsten and Benedict will tell you something more about it later on. So we do now the outside contour of the part. It's a small part. We also have a bigger one. But I will show you the small one. Don't too boring or let you sleep in. You know, in Germany it's now 11 o'clock in the evening. I know in Australia it's a bit earlier than here, but we are now nearly finished with the part, you see. And we now can open the door. I don't want to touch this part now because I think it's quite hot. But this is nearly the same part. We done it a couple of seconds before in the last event, and yeah, that's 30mm cutting with our flagship product, the Bystar Fiber, 15 kilowatt. And with this, I will hand back to my wonderful colleague, Sarah.
These are great news, Eric. Thank you. So this 30mm part is not only there to show you how fast and precise we can cut even in thick material. So this Bystar Fiber 15 kilowatt laser cutting system is also a part of Bystronic's future. So Carsten, can you tell us more about Bystronic's future?
Ja, damit, sorry, wrong language. So with this, we have seen our brand new B-Star fiber. We finished the installation just today. So it's brand new 15 kilowatt, as Eric just mentioned. And the idea is now, for example, we can do this demonstrations here with thicker material. And it's not just a demonstration. The idea is also that we can cut now parts of our frames, for example. That's something what Eric already mentioned. These are some parts for the new B-Band Star 120. The new B-Band Star 120 is the newest product which will come out this year. And this machine was coming out at the workshop. We have done shortly after the launch of the Expert 80. The Expert 80 is a machine with 80 tons by 1.5 meters. We have done a workshop, and the workshop target was to find the perfect mid-size automation. And then in this workshop, we discovered that we need to have one additional bending machine as well. And this is the B-Band Star 120. This machine will have 120 tons. It will have a bending length of 2 meters. So this means 120 tons. Expert 80 has 80 tons. The next bigger one is our Expert Pro 100 tons. So it's something in the middle, or let's say already a little bit bigger. This is the reason some customers told us we would like to have a little bit more again, more than the Expert 80. And they told us also a little bit more bending length, and that's the reason why we have now 2 meter bending length instead of 150. So this machine will have 2 meter bending length. It will be our new, the start of our new flagship. This will be the beginning, as I told you, 120 ton by 2 meters, and then we will have a 120 ton by 2.5 meters. The idea of this is, or the customers told us, it's a perfect machine for job shops, for example, because you are really flexible. You can bend easily parts with a material thickness of about 8 millimeters over the complete bending length of 2 meters. Of course, you can bend also thin material with it, and with high tolerances. And you can bend even thicker material. We have just seen here, we have been cutting 30 millimeter material. So even this you can cut on a bending length of around about 1 meter. So you have plenty of power available in this machine. It will be also really fast. This machine, it will have more or less the same bending speed like the Expert 80. So it's a really fast machine for bending small up to medium sized parts. And as I just mentioned, this is typically for job shops, but also for agriculture industry or for transportation industry, for mining industry, everywhere where you have thicker material or material with higher tensile strength. So keep in mind, B-Band Star 120, this will be launched during this year from Bystronic. So with this, I hand over to Benedikt.
Yes, we have seen software topics for the laser cutting. We have seen laser cutting. And to close this topic regarding laser cutting, I want to invite you again for our Slido question, our next Slido question, to get your opinion regarding cutting. And the question we want to ask you is, if you use laser cutting systems from Bystronic, which material thickness do you cut usually? Is it below 5 millimeter, the thickness of the parts? Is it in between 5 to 12 millimeters? Is it in between 12 and 20 millimeters? Or is it, as we have seen here on our laser machine, on our Bystar fiber, is it over 20 millimeter, for example, 30 millimeter? So I invite you here to vote also here on our Slido question. Join in again, slido.com. With the code 952 or with the data matrix code. So we have one answer already, 2 answers. So these are more customers who cut parts below the 12 millimeter. One of you answered below 5 millimeter cut parts, but we also have some who vote for over 20 millimeter. So
yes, exactly.
now 5 between 12 millimeter is leading. So this is the common thickness, part thickness, which is cut in Australia. I can see here. Maybe
it's still changing, and it's interesting. No? It's we have done something like this already in November last year. The results have been always really different depending on the countries, the people coming from. And as I mentioned before, with the new machine which will come later this year, the B-Bend Star 120, you can of course bend also thinner material with with highest accuracy. And we will have also on this machine, for example, lamps. We will come to this topic later on. Laser angle measuring system. This will be also available on this machine. But we have plenty other machines also available now already. And this is, for example, our Expert Pro and our Expert 40 and our Expert 80 and our automations. No? So we will all see. We will see all these machines. But let's see. We have now a number of voters here. So most people in Australia have material thickness between 5 and 12 millimeters.
Exactly. And what do you do after you have cut your parts? You have to bend your parts. And with these words, I want to overhand to my colleagues. And they show you how products we offer at Bystronic to follow the process after the laser cutting.
From cutting, we are going straight to the creation of bending programs. Our intuitive and modular software, Bysoft 7, can not only create cutting programs, it's also applicable for bending. So, you know him already. Benjamin, it's your turn again.
Hello, my name is Benjamin, and today I will demonstrate how we import 3D parts in Bysoft 7. How we unfold them and how to create the bending and the laser program in a full automatic way. We create and import 3D parts normally with the designer. The designer is our CAD module. And sheet metal parts can be bendable, constructed, and imported here. File formats such as STEP and STP files and SAT files, as well as native data, can be imported here, and the processing of assemblies are also possible. Today I will show you how we can import all this data with our new module AutoPart. The AutoPart module enables you to process 3D files, 3D parts, and assembly fully automatically and create bending and laser programs. In addition to STEP and SAT files, native data and assemblies can also be processed. The assembly will be separated and correctly unfolded at the same time, and the flat and the bend program is created. Non-sheet metal parts are recognized and filtered out independently. So I will start the automatic, and we will see how the program will unfold the parts, set the right bending technology and the right cutting technology. The parts inspection shows you at a glance whether manual post-processing is necessary or the component is finished. The components are automatically saved and ready for the production. On this part we have a warning, so I open the part editor to check what's wrong with the part. Bystronic works with the traffic light colors here. Red is for not productable, yellow is for a warning sign, and green is for error-free. In my example, a contour is recognized in the entry zone of the bottom tool. This can now be provided with a relief cut independently and quickly. A change, an alteration to the geometry requires the bending technology to be restarted. The bending process is now simulated and the feasibility checked. The existing top and bottom tools are loaded from the virtual tool cabinet, and with the automatic bending technology, the part is automatically shortened correctly, and Bysoft 7 works with an empirically determined values which ensure that the parts fits perfectly. The bending sequence, the tool setup plan, as well as the package position and all further process steps are also created automatically. It is possible to intervene manually and at any time, and flexibility adapt the process steps. The operator can change tools individually, edit the bend sequence and define the package position. Here we can see the estimated bending time, and we can see the cutting time for the laser. With the tool setup optimizer module, the bending programs created are now put into the optimal sequence in order to minimize the setup process on the machines. Here you can see the different parts from the auto part module. A bending job with several bend parts is created as a package. The bend parts are loaded and put into the optimal order using the program tools and the station plan. Tool time, setup time, and bending time are taken into account here. The operator of the machine can thus start a job once and guide it through the shift. Now it is possible to switch to our other program. It's called Cost Calculator. And with this program, it is possible to do a perfect part cost calculation. Here you can see we have different laser machines and different process steps. So we can choose if the part is will be cut on a B-sprint fiber or on a B-star fiber. So I can select the right cutting machine. And now we get the costs for this part. We can see the material costs, we can see the process costs. and can send this information to our ERP system to have a perfect calculation for an offer or something else. This is how quickly and easily you can create perfect laser and bending programs with Bysoft 7 in a full automatic way.
Good job, Benjamin. So let's continue with the bending technology for highest demand on process speed and flexibility. Our flagship, the Expert Pro, highlighted by the dynamic crowning and the laser angle measuring system presented by Ronny.
Hello, good evening and also good morning from my side. My name is Ronny and I like to explain a little bit the dynamic crowning and the laser angle measurement system. For the crowning we have this part, we have a long part, it's around about 1 meter long, and we have also these holes inside that we can a little bit explain how the crowning is working on the machine. What do the crowning? You can say easily the crowning is for this that you have on every place on the machine and straight angle. On every place we have the same angle. Later on I explain also the lamp system. This is a measuring system that we have the exact angle on the part. This is that we have for all places on the part the same angle. Okay, how we can look for this? First of all, we need a program for the part. I don't program the part in our offline software. I like to show how we can program this on the control. First of all, of course, I have to say what kind of material we have. We have already selected by steel. This is the normal steel. I select the right thickness. If I change the thickness, let me take 1 millimeter, then you see I get the selection for the tool. In our case, we have 5 millimeter. Oops, like this one. And I will change for the higher tools, of course, and maybe the V32. Then we have to bend 5 bends, 1, 2, 3, 4, 1, 2, 3, 4, 5. This is very simple. We search a start point, then we can slide with the finger around the screen, and then we can select the bend length. We can also just touch like this, and we can go to the table, and here we can also type in our band length 50, 50, 50. Here I take a mistake, 50, 1, 2, 3, 4, 5. One I have to delete maybe. Like this. So this is also 50. Then we have programmed our part. We take over the part to our software for the bending machine. Say, okay, I like to produce the part. The software calculates the right bending sequence and also the place we have to put in the tool. This looks like this. You see also on the optical bend guiding system on what for place I have to put the tool. In my case, we have the tool changer. They are changing the tools automatically. We will explain this a little bit later. Just for this, I go to fast change, press the start button and hit the OK button, and then the tool changer change the tool. And this time I can a little bit explain more about the part. First of all, you see I have these holes inside. I will start maybe from this side. The machine knows just for 1 meter bending length. We can hold the part like on this side or on this side, doesn't matter. We have also some small parts. These are our reference parts. I take just one of this for the first bend. We can hold this in the finished part to check that the bend angle is on every place, on every bend the same one. And this is the first bend we will do, and then we bend all the other bends for the part, and you can also see what the machine will do. I will switch on the crowning compensation page, and then you see how the crowning is adjusting during the bending sequence. This will be adjusted dynamically. This means we are measuring over the pressure sensors on the machine how many force we need really. And if we need a little bit more, then of course the crowning is more. If we need a little bit less crowning, then the software say, okay, I adjust the crowning a little bit less. Okay, the tool changer is finished. We go back to this area. Let me go to the produce area, and I will switch on the compensation page and the crowning area. Okay, first of all, I bend just this small part. This is our reference plate. You will see if I take the bend, we need very less crowning. We wait for the safety system. This is moving down to the exact height of the tool, checking is the tool the right one, and then we can start in fast speed. Okay, we do the bend. And you see, let me go back to the first bend. We have very less crowning. On the blue sign, you see there's nothing really moving. I place the small part here on the side, and then we start with the big part. So first we place the backstops, and then we start the bend. And now we see we need a little bit more crowning, and of course for every bend the holes will be smaller and smaller, and we need more force for the part, and we get more and more crowning from the machine. So for this part I just programmed the bend length of 1 meter. Of course the machine don't know about how big are the holes here. Yeah. So the second last bend, and now the last one. This is of course in the full material, and in this bend we have the most crowning on this part. Let me place the part on the side that you can see it, I hope, like this. And then I take my small part. You see I place it on every bend, and I can also place it on the bend in the middle, and the bend angle is exactly the same. This is the most important thing for the machine. Also in the middle of the part and on the end or the other side of the part, this is the same. This do the crowning system automatically. So now of course we have a straight bend over the whole length. Doesn't matter on what side you are bending. How we get the right angle, for this I show a second part. Then I can a little bit more explain about this. Let me take this one. Don't need to save the new part. Let's change also the tools. Say yes. The tool changer is changing the tools for this part, and I can a little bit explain this one. You see this part looks a little bit more complicated. We have different angles, and here we measure the angles that we get. The first part is a good part, or the first bend is a good bend. We have different angles here, I think 100 or 110 degree and 90 degree, and we have also some small bends in the middle. And what we can also do, of course, is if we cannot really measure the angle, we can also say, okay, one time I measured this already on the part, I take over the value to another bend, then you don't need to measure on every bend on your part. What you can also do, I will show it on the last bend on this part. If you are not really sure what kind of material is it, or the variation of the material could be very big, then you can also say, okay, I'm not really sure what is the spring back of the material, I will measure this. The first bands you will see, we do a normal compensation over the lamp system. They are measuring the angle, make a compensation. This goes automatically and really fast. And on the last band, then we measuring also the spring back, and the software can also compensate the spring back. Okay. Let me start. We go to the produce area. The first band looks like this. Now maybe you see, I can a little bit move it to the side. You see the safety system is also moving down to the high of the top tool. And we have in additional this little devices in front and also in back for the laser, that we can measure the laser. The laser can measure the angle of the part. Okay, let me start the first band. So, band number 1. Then the second band. These 2 bands, I can use the measuring device. For the next band, you see it's very close, and I hold the part a little bit difficult in the bending machine. And for this, I take over the measurement from the band before. And for this also, this is very close on the side. It's like this. And on this band, we can already measuring the angle. Maybe some technical things. We need around about 50 millimeter for the flange length, or outside the tool that we can measure the bend angle. So the second last bend. Here we take over from the band before, and for the last band I explained it before. We measure the spring back on the machine. You will see it, the machine bend 90 degrees, release a little bit the material and re-hit, and compensate the spring back also. Okay. Then we have the finished part. This looks like this. I hold this in the camera that you can see it a little bit. The angle measuring system is for the first part is a good part, and you don't need to do a correction. This was a fast introducing in the compensation systems, especially crowning system and the laser angle measuring system. Okay, this was from my side. I give back to Sebastian. Thank you.
Thanks to you, Ronnie, for these great impressive insights. And we have more awesome news, especially about our laser angle measuring system. Carsten will tell us more.
Yeah, maybe before you, Carsten, tell us more about the laser angle measuring system. Okay, so some technical problems, sorry for this. Before you tell us more, Carsten, about the laser angle measuring system, what came up to my mind is that the Australian visitors voted that they are most interested into laser cutting. And we have seen that most of our visitors cut between 5mm and 12mm steel parts. But we have shown today the 15 kilowatt Bystar fiber. What is the benefit compared to the products we had before, like a 12 kilowatt or 10 kilowatt laser? Is the 15 kilowatt really faster? What is the benefit?
I think that's something what is really you can find out in a live demonstration, for example, also in Switzerland with the colleagues from the laser side. They have much more details because, as you know, maybe. First, there was something like a 6 kilowatt CO2 laser, and everybody was thinking, "Whoa, this is the end." Then the fiber laser came to the market. Then there was a 6 kilowatt fiber laser. Then there was 10 kilowatt fiber laser. Everybody said, "Oh, this will be enough." And now we have here 15 kilowatt fiber laser, and we are sure this will be not the end, because that's what we have seen today. Also, we have been cutting really the thick parts, and that's something what the laser colleagues are telling us, that about 40% more time you get out by cutting this kind of materials, between 5 and 12 millimeter, when you go up to this 15 kilowatt. This is exactly the range where you can earn additional money, and this is something what you can find out also when you send your parts or your drawings to us, and we can do a live demonstration just with your parts individually for you. What's also important, what Ronnie was mentioned downstairs on the Expert Pro machine, it's the LAMS, Laser Angle Measuring System. Laser Angle Measuring System, about 50% of our machines have this device. This ensures that you have first part, good part. The next generation of this laser angle measuring system will be also available from the middle of this year. What does it do? It does the same as your next generation of your mobile phone. It's just faster and better. The camera system is much faster again, so you have about 30% more speed in this again, and the accuracy is increasing again, or the reliability, because we have different optics inside and different laser which we use for measuring. So this is something I just want to highlight. You can find out more in our competence days in the middle of the year in June. This will be taking place in Switzerland. And this is the next generation of LAMS. Before we go on with the next topic, I would like to highlight again this. We have the question, what is the most time-consuming process in your bending process? So we have seen just now tool changing, for example, for everybody who was working together with a modular tool changer. I think the people know that this can save a lot of time and also give safety to the operator, because he can't put in the wrong tools on the wrong position, and it can make the life of the operator much easier. So this is the next question for you. As I told you, in Slido, you are really welcome to come go with us into Slido again. Here is our code again, our event code. It's B952, and it's the question, what is the most time-consuming process? It is the correction, what somebody just mentioned. Is it tool setup time? Is it getting part to the machine from the laser? Is it programming of the parts, or is it redoing waste parts? Maybe you are, Benedict, the product manager for the vending automation. Maybe you have some more details about this.
Yes, when I mostly talk with customers, they say it's really the tool setup time which is most time consuming, especially if they produce small batch sizes of parts. But also what Carsten mentioned before is redoing waste parts is also a big topic, because for sure a tool changer will always position the tools at the right position. So you do not have to correct something, you do not produce waste parts because of wrong position tools. So also this is really a big topic.
Yes, and I can say to you from my side, I'm responsible for the demo center. I'm really happy when you join us for a demonstration, and I bet with you, if you decide for a tool changer, you will never come back to us and tell this was the wrong decision. I bet with you about a box of beer, German lager beer, so you can come to me and remind me on this bet after you have your first tool change on your factory, and I think you will never come back to me and say it was the wrong decision. If you tell this to me, you get at least a box of beer from Germany. Some people think it's the best beer in the world. I am, for example, but there are also other good beer in the world, I know. So with this now we see here, tool setup time is 50% voted this. It's you can calculate this very easily. You know? If you look at your operator and you see what he is doing there, then you see that this is really the process time where you can save most money still. So with this again, I want to highlight this, and you find this also in the chat, in the live chat. You can go to this direct link to our landing page for web demonstrations, and you can book your web demonstrations very easily. You have just 3 steps. You choose your product you want to see, you choose the date, and you send it to us. And then we organize a web demonstration individually for you. So with this, I hand over back to Sarah.
So what we have seen so far, let's come up to our latest Bystronic technologies. So we saw the B-Star fiber with 15 kilowatt for the 30 millimeter cutting, and our upcoming mid-size press brake, the B-Band Star, and our flagship, the Expert Pro.
These are amazing developments. As you can see, Bystronic is a company which is always in shape to expanding its product line. So just the best choice.
So that's right, Sebastian. But nevertheless, there's one more thing for you guys. We saw cutting, we saw bending, but there's one more left: automation.
One of the best-known faces of Bystronic, Gerrit Gerritsen, will show you how easy and fast we can program a part in our Robot Manager. The Robot Manager is our software for our automated bending machines. And because this is an international event, we switch directly to Switzerland, where Gerrit is.
Bystronic is a leading global supplier of system solutions for the sheet metal industry. We provide laser cutting systems, bending systems, automation, software solutions, and comprehensive services.
Sorry, I need a sip.
He's good, no?
Mommy,
Let's say he has a confident voice, yes.
Shall we? Client happy?
Client happy, but please get to the end of the line this time and add a little verve.
The verve is there. You may not be able to hear it right now, but you will in post-production.
In post? We are in...
We offer worldwide presence and competence. We speak your language and understand your needs. We are here for you.
Sorry, we are here for you. I mean, I hear the words, but I'm not getting anything from them, you know?
Could you please just say the lines?
May I?
Please.
It means that we offer much more than just a machine. We support our customers with flexible financing models, training, maintenance, a long-term spare parts service, phone hotlines and online support. And we also operate local sales and support offices in many, many countries.
Yes. Now you see, now it's
coming alive. We should be saying this.
It is more text, though, so we will have to renegotiate with my agent.
Can't you just record it and we'll look at it later?
Well, I'd love to, but my agent would kill me.
If only. Fine then, continue with the script.
Right you are. Where were we?
At customer service and post-sales services, would you believe?
Rolling.
We don't simply develop machines that cut or bend sheet metal. No, our customers need flexible systems for ever-changing order positions and batch sizes. Automation to achieve top productivity with integrated systems and the right software that cross-links everything. Bystronic stands for Swiss quality.
Sorry.
Really?
Swiss quality. I mean, it's a bit of a cliche, isn't it? And actually, while we're at it, your slogan, best choice, kind of sounds like we've just won the buzzword bingo.
Guys, if you want to sort this out, I'm just going to pop out for a smoke.
Let me explain. First of all, Swiss quality. Do you know the Bystar fiber? The Bytrans cross or Bysoft?
Good morning. I'll show you how to program a part on our new robot manager. This is a software we developed to program our robot cells, and it's extremely easy. Right here you see the main page. I can open parts, that's what I'm going to do. These are the parts I used last. These are already projects which exist. And here I have my customer database where I can find parts which I want to robotize. So I take this one here. Here I choose my cell. I know that I have this cell, choose that one. And now we get to the main page of the robot program. And here we have to choose, for example, the cell, the grippers and everything. I can check my part again, double check it. All right, this is the cell. So I see my pickup pallets here, I see my chute, I see the machine. I can switch different things on and off. Yeah, normally I want it like this. This is the easiest to program. So what I need to do here is to choose a gripper or a vacuum cup. That's what I did, and then I make a program. So that's what it does here. I can verify all this. I don't want to do the dual sheet detection. I know that my parts don't stick, so I'm fine. Create a program, and it will now make blocks. For this program, I need 2 blocks for the bending. They're right here at the bottom, and then home position pickup, that's where I am now, reference, and drop it in the chute. So this is where we are, and this first bit is about the part itself. So I need to tell the machine where the part is. So I say, yeah, it's here, it's fine. Next position. What we've tried is to use as least possible this side here where the numbers are. I don't want to type numbers. I hate numbers. So here, this is the reference table. Parts should drop in this corner. So what I do is I let it drop. We calculate. We have a physics engine in here. Friction, gravity, inclination, and it drops right here in the corner. So we're good. Last bit here is how am I going to let it drop in the chute here. Like this. Maybe put it in a little bit more. A little bit more. There, that will drop, no problem. And once I've done that, I'm finished here. There's no more black arrows. So next one is the gripper positions. I need to do the same thing again. And what we've done here, something very clever. I have a before and after view. So if I make a movement here, I can see the result of that movement here. So if I make this movement too big, then it results in a crash here. I don't want that, so put it back. Normally what we calculate is pretty good. You don't need to touch it. So next position, from here to here, that's fine. And then first bend, second bend, and then drop it. Again, if I want to move something, I can move it, no problem at all. Put it back. And again, also here, of course, if I touch something, it will get red, and that's basically a bad idea. I leave it like this, so that's basically it. At the bottom, everything is yellow. That means that I've done it, and now I need to create the robot program. So first I hit this optimize configuration. Now the software tries to eliminate unnecessary movement. It's done that already, and then check. Now it's connecting all these blocks together, and if there's a collision between blocks, like I have here. It's red, this is red, there's a collision. Also these little dots indicate the collision, so if I go there, then I can actually see the collision. It will go through this thing here. That is not a good thing. But we've noticed that there is this collision, so we've already done the next step. We've created these two blocks in between the other blocks. So here, these two red blocks are points in space, which have not been calculated yet. But if I push this button, it's calculating. So we add points in space, and now I have a complete collision-free robot program. So this is it. This is done. What I can do now to make more autonomy in the cell, for example, I can make a stack pattern. Here I can say copy this one in the Y direction. So I've got two now. I can enter my pins. I want a pin here. I want a pin here. This is for the operator, to shift his parts against. One here, and I see that this one is red now, so I need to move it a little bit more like this. That's okay, and then I can do the same thing for the place position. That's here. Again, I can just say copy this one, copy it once more, like that. Yeah, fine. So I don't get a big pile in the end of my pallet. I get a nice 3 little piles. That's much better. I need to calculate these paths because I've added positions. So I hit check again. So it will recalculate everything. The middle bit, it will stay the same because I didn't change that. And now I have new positions. Everything is green. The pickup positions are here, and these are the shoot positions. And everything is done now. I can run this. I can choose here which one I want to see. This is the first one. Reference position here. It's the middle one. So let's simulate this. We choose the views automatically, so the operator can see exactly where the movements are. This is happening 100% in real time in the cell also. You can block the view with these little buttons here. So now our program will keep this view until the end of the simulation. I will unblock it because otherwise we can't see where it drops the part. So bend number 1, bend number 2. So I wasn't talking, then making a program like this will take 2 minutes, 3 minutes maximum. Of course, if it gets a little bit more complex, I'll need a little bit more time, but it's still super easy to make programs with Robot Manager. I'll unblock this again, and then it will put it on the output here, and then it will go back to the home position. So that's it. I need to save this part. I need to export it to the machines. That's what I do here. Save, and then here, and it will also make a drawing with where the operator has to put these pins, the pins for the table, so he can put them in the right position. And that's it. I'm all done now. Another little feature in our Robot Manager. Of course, when you do some automated production, you need stacks to pick your parts up, and it would be nice if you could have stacks also to lay your parts down. And that's what I'm going to show you here on the Robot Manager. So I've done the part. It's the same as before. I've changed the cell. So now I've got an 80-ton, 1.50 meters, and I've got this conveyor to show you better what I'm going to do. So this is all green like before. And then we have to go to the stack pattern. Stack pattern, here I see my pickup place. And the easiest thing to do would just go here and say copy, duplicate, and then it made another stack. That's easy, make one more. There, I've got 3 stacks already. And then I can also duplicate everything here to another pallet. This is the other pallet, duplicate here. So now I've got already 6 stacks, so this can run for hours and hours. I'm going to take them away again and show you some more details. Here, pallet 41, that's this one here. Also this one here. Let's leave these 2 stacks because it's not done with only the stacks. I need to put these pins in. I need to reference the parts. So I'll put a pin in here and I'll put a pin in here. So this is fine. You can push your part against this pin, and then it's referenced. And the same thing, put a pin here. It's there already. And one here. So if I would duplicate the stack now, it also duplicates the pins, of course. What's happening, we're checking collision with these pins. Of course, first of all, the parts against the pins, but also the robot against the pins. If you put everything full of pins here, the robot cannot get to the last sheets on this stack anymore. Also, we simulate and we make the program in the way you've put the stacks down. So this is the first one, second one, third one. You cannot start here in this corner because everything would be full with parts. It doesn't work. So this is okay. Then again, you can still see that there is a little bit of space here. That doesn't really matter, you know. The moment you touch the pins, it gets red, but it doesn't need to be that precise. If you're within, let's say, 5 millimeters here, that's good enough, you know. You don't need to make really precise, super neat stacks. They're going in the reference table anyway, so you're good. We also have customers who just put this stack against this one, so they save pins and of course they save space also. So this is the pickup stack, and then we go to this stack here, the place stack. One part already, and again here I'm just going to copy it. There I've got a second one, and then I'm going to put a third one on top of it. And since we don't have an automatic function for that, I need to move the part up a bit, move it over, and then maybe maybe twist it a bit like that. And this is my output stack. So very easy to do that, no problem at all. And then what I still need to do is, of course, make the program for all these things, because I've actually made now 2 different programs here and 3 different programs here. So I go back to paths. Here we see it's like a little railroad. So this is the original one, and these are the ones I added. Also here I see the other references, and here I see 3 place stacks. So I run check again. It's going to simulate everything again. Once this is green, maybe it's not all green, maybe I need to change 1 or 2 positions. It's all green, great. So if I want to see that last, this one here, the second stack, yeah, and then I can simulate it, and you will see here at the beginning that we will pick up from here. So it's already made the program. I'm just showing you the simulation. So running through, referencing, and it's going to do the 2 bends. So I've actually made now 5 little different programs. You can use up to 4 different parts in our cell, the little cell. So you can have 4 different parts on these 2 pellets, and the moment your tools are okay, you can swap between parts automatically. We make a job list, and you can swap from one job to the other automatically. So you can have like 8 hours run in that cell, no problem at all. It is already the last bend, and then it's going to put the part on the conveyor there where I put it. This is the second place. And there we are, program done, everything done, we're good to go. Thank you.
Sorry for the little delay at the beginning. We had some problems with the connection to Switzerland, but now we are back in Gotha and can go ahead.
So nevertheless, thank you, Gerrit, and grüezi to the wonderful Switzerland. So from the robot manager, we go straightly to Eric, and he will show you how one operator can handle 3 machines at the same time.
We are starting with the bending cell for fully automated tool changing and bending process.
So at the same time, Eric will also present you the most flexible form of automation for fast and precise tool changing, our modular tool changer.
And last but not least, there is enough time for our powerful mobile bending automation in its most flexible form. Our mobile bending cell combined with the Expert 40 with conveyor belt. Eric, go for it!
So hello again from my side. We are finished with the laser. Now we go to bending, and I send my colleagues now a little bit to a coffee break. And in this time, I'm alone here in the demo center, and I will show you all our automated bended products. So we will start with our biggest one here in the showroom. It's the bending cell, and we will start with a little walkthrough around to show you all the main features of that machine. So maybe some words starting with our machine. It's an Expert Pro, as all our machines in the bending portfolio of the mobile of our automation. So we have an Expert Pro. It's available in the tonnage from 100 to 320 ton, and it's also available in 3 and 4 meter bending length. We are also can equip this machine with the laser angle measuring system, which guarantees us really good, constant, safe bending accuracy from the start to the end of the bending process. The machine can also equipped with a 6-axis package system we see here. It's a little bit special because we have contact fingers attached to it to give the robot the information how we can go on using the back edges, or we can have found the back edges. I stand now in front of our pickup pallets. So we have 2 pickup pallets in this setup of our bending cell, but we also really free, and we try to give you as a customer the most flexibility around the bending cell in the layout. So we can have various layouts for the various machines. We can also have loading pallets in front. We can also have unloading pallets here. We will see now a little bit special things. So we will pick up the part from this pallet and set it down on the same one as well. So we have these 2 steel pallets. We will see them later on also in the small robot. And we have these steel pins to make sure that we have aligned the parts correctly to our pickup pallets. We have separation magnets attached to make sure that we can easily separate steel parts from one to the other. The next big thing here is our alignment station. So we have to align the parts after gripping it to make sure that we have the correct position of the part to go on to the bending machine to make sure that our bending result is every time perfectly during our process day. Then we have the double sheet detection and also the material thickness measurement system, which we have here. It's a little pressure sensor which measures the thickness during our bending process. So now we go a little bit further through the machine. What we have next is our regrip station we can see here. Now you can't see the arms quite good because they are in parking position. So we have 2 arms, they can move together to regrip your part, to reorientate the gripper. We can do it here. And we can do this with 4 suction cups. So we have 2 suction cups in the top, 2 in the bottom. We can move the suction cups to the right-hand side. And we also can put the arms together to make sure that we can regrip all the parts you want to bend on this machine. Also, we are able to use clamp grippers. So we have 2 clamps, 1 in the top. No, we have 3. 2 in the top, 1 in the bottom. And so we can also use clamp grippers if a suction cup is not usable or useful. And what is also in this regrip station is the turning station for the tools, because our bending cell can also change tools fully automatically using the robot. And therefore, we have our tool rack in the back, so we can store various tools from various sizes. So we can have V6S to V120 in the lower tools, and we also can have various range of upper tools during our bending process. We can store them in here, so we have various range. And for you as a customer, it's really interesting how we can load new tools into it. So it's not like teaching them in, we're just hanging them into our tool clamping, and then the robot will fully automatically scan the tools and give them a position in the tool rack. So what we have here in this line is our gripper depot. So we have 5 gripper trays attached to the bending cell. The first one is saved for or reserved for our tool changing gripper. So we can change the tools with that, and then we have various range of different tools, different grippers. We can have magnets, we can have vacuum suction cups, we can have grippers. So we have a various range. You see some of them. We have like a 4 suction cup gripper here for a bigger part from a customer side. We have a small suction cup gripper here. We have a 2 magnet gripper there, a small one, and we have the really big one, magnet gripper over there. And then we have various grippers in the gripper tray. So if you are interested in a demonstration of all the grippers and also your part on the big bending cell, then feel free to book them using our new landing page. And now we want to see the machine running, so I will start up the process of bending. So we go out of the cell, closing the door. And now we can go on with the process of bending. So we pick up the part, the first one, searching for it using the magnets, and then we go to look for them. First part is attached. We go to the alignment station to align the part, re-grip, double sheet detection, re-grip the part, and now go to the bending machine and bend the first angle. We have 2 in this. We are also able to use the following function, so we can support the part during the bending process. It's not necessary with that small one, but if you have bigger parts, then it's also able to change them using the gripper. And now we can leave the machine alone. They will produce some parts. They set down the first one now. Now we can go to some more, and in this time we will go to our modular tool changer. Yeah, and yeah, I'm again, so you see we're good now. Yeah, modular tool changer, our modular system for automatic tool changing process. And what is a really plus point of this machine is that we are, as it in the name, we have a modular system, so you can have the opportunity to buy the machine now and sign the contract for the modular tool changer tomorrow, next month, or maybe next year. So we try to grow up with you as customer in your company. And for this, you see, we have the tool setup plan my colleague Ronnie has used before. And now we want to go easily over the following process, so we can now change the tools for the second job I will bend afterwards. And for this, we use the robots. So we go on fast change to start the tool changing. One of the most important features which saves you a lot of time called smart routing. Smart routing means that we don't put away any tool we use later on, we just move them into the clamping. We have various functions to make sure that the tool change process is efficiently for you as customer, to make sure that we have not so much clear drive, so all the movements of the robot will taking a tool to a different position. You see, we move this tool to the left-hand side, change this tool to the other side, also using this one for the lower tools, to make sure that we have a most optimized tool changing process using the modular tool changer. What you see maybe in the back of the machine during the machine is changing, we are able to store tools in 3 tool cabinets. So we have 2 in the side of the machine, we have 1 in the back. And so we have a various range of tools. In lower tools, we say we can have V6S up to V120 with a maximum tool load of 25 kilograms. And in the upper tools, we can have also 25 kilogram tool segments, P4, P5, P7, so standard punches, we can have crop punches, and so on. So we have a various range with upper tools, and there is a little bit special thing. We have 550 millimeter tools, 350 millimeter high. So we have really, really big tools in this machine. And we also have various upper tool heights, so we can have 550 millimeters of 55 millimeter high tool, and also with a tool height of 100 millimeters. So we are in a wide range using our modular tool changer. And now I will go to my next job with the MTC, and then we will go over to our mobile bending robot, and in this time our MTC can change some tools for us, which is also possible to give you the most flexibility of the modular tool changer is that you're able to change also tools manual together with the MTC, so you can mix up your tool setup plan to have the most flexibility during your job life. So we will do a fast change with all the tools, and then we can go over to the mobile bending robot. So mobile bending robot is one of our smallest products in the automatic range. So we can have the MBR with a 40 ton by 1 meter press brake, and also with an 80 ton by 1.5 meter bending length. And with this, we can have also little batch sizes because of the fast programming with the robot manager for this machine. And we can have various setups also with the ejection of parts. We can have standardized a part slide, but we also can have the conveyor belt as the setup is here in our demo center. We have 2 picker pallets for different jobs in here to use different jobs in a row, like on the machine, on the big bending cell. So we can work a job list through. And also we can have these pallets using the forklift to change them really quick, to have a short setup time for you as customer, to make sure that we have various jobs quite quick changing with this machine. The Expert 40 is standardized, set it up with a 6-axis package system to give you the most flexibility also with small and complicated parts. We have contact fingers attached to this to make sure that the robot knows, okay, the part is attached now. And we also have the conveyor belt. And now I will start also the MBR and let all the parts working through during the whole bending process. So we can start now. Robot will take the first part and then again go to the alignment station, pick it up, bring it to the bending machine, bend, and then it will put the part down to the conveyor belt and feed them out afterwards. Quite easy, quite simple. And what you see on this machine is a really quick, simple setup for the MBR, also for the MTC and the bending cell. All machines were running properly now. All machines are producing parts. The MTC will change the tools for us to go on with the next bending steps, to go on with the next bending parts. And I let now the machine a little bit working. The conveyor belt will feed out the parts now to give the place free to new parts, for new parts. And yeah, all machines running. I think we can now go in break. I can hand back to my colleagues, Sebastian and Sarah. My job is done. I can let now our automated systems work, and I can go to coffee break now. Thank you very much from my side.
Well done, Eric. So our expert Benedict will now tell you more about our automation.
Yeah, thank you, Eric, for this great overview of our bending automation products. As you can see, especially in these hard times we live at the moment here with the coronavirus, and that you maybe also have the problem that you do not find the right operators for your jobs. We have seen that it's also possible to handle 3 different machines with just one operator. So we see it more and more that also for the bending processes, bending automation is really the key to cover also phases as we have at the moment. And especially also, if you have operators and you have very experienced operators, it's always a big topic to also protect them. This is also the reason why we can handle with our Expert Pro combined with the modular tool changer the heavy and the big tools, so tools up to a length of 515 millimeter, from smaller dies V6 up to V120 dies for really thick material which should be bended. So this is also the reason why our modular tool changer is available for our 4-meter machines and also for our 320-ton press brakes from the Expert Pro series. Another important point is especially as you have seen on our big bending cell, that the handling of big parts and also heavy part is always time consuming. It's hard work for operators, and often you need 2 operators for these big parts. With an automated machine like our big bending cell, this job is completely done automated by the machine with no need of an operator, and cover big jobs by its own. And also special, what was to see, is our mobile bending cell, our most flexible version of bending automation system to produce smaller parts in high batch sizes, but also to produce smaller batch sizes with this bending automation system because of this easy and new robot manager programming software we have seen. Maybe you want to add some things also to our bending automation products at this stage?
Again, I just want to invite you for your live demonstration with your own parts. We have everything here available, all the automation products we have available. Just send your parts to us, and then we can make a live demonstration with your parts here in the demo center via the web.
Yeah, was great to see these 3 products running in parallel, just operated by one operator who is covering all these 3 products, and also 3 different applications which are running on 3 different machines. And to give you more insight, I want to hand over to my colleagues again, Sebastian and also Sarah, who will give you an overview what we are looking at next.
Eric also spent some time with our customer Kevin Rotauge. He gave us a fantastic inside view of his production with the modular tool changer.
Yeah, welcome everybody here now from a little bit different location. We are at customer site in the beautiful town of Speyer at the customer Rotauge Schneidtechnik. And we are in front of an Expert Pro 320-ton by 4-meter as modular tool changer. So you can have the modular tool changer in the range of 100 tons to 320 tons, and also from 3 to 4-meter bending length. So some words about the general features of that machine. This machine is equipped as 320 tons by 4-meter. We have arranged a T12 table here, which is a bit wider table for handling also lower tools up to V120. We have an RFA upper tool clamping here for handle our tools fully automatically with the modular tool changer. Then we have equipped the machine with the optical bend guiding system in the upper tool clamping, which guides your operator through the bending steps in your bending process. It shows you the position of the back edges. It shows you your pressing force, and also it shows you where you have to set up your tools. And new for this machine type, for all experts now, is the optical bend guiding system in the table. So you also have the possibility to see where you have to put your lower tools into the tool clamping. Basically, the Expert Pro machines are available in 3 speed classes, starting with the Classic Edition, going over the Performance Edition, and on the top side we have the Dynamic Edition, which we have in the back here, so we can handle up to 25 millimeters of bending speed. We have also equipped the safety system for your operators to keep them safe, which is electrical high adjustment. It calls Fast Bend Plus, so it will every time fit to the correct programmed height of your tools. And also the machine is equipped with the laser angle measuring system to make sure that your first bend is a good bend and your first part is a good part, and that you can measure and also correct the angle during the bending process. Okay, what I have forgot, we have a sheet support here, the small one, which can handle up to 150 kilograms. We are able to have 2 on this machine type. In this setup we only have 1, and we have 2 support arms to handle as best as possible for your operator. Yeah, that's basically everything around the machine. Now we go in the backside to see a little bit and talk a little bit about our modular tool changer. So now I want to show you also the inside of the modular tool changer. So what is the biggest thing in here is the robot. We have set up here a KUKA robot which handle the tools using an air nozzle to blow out the lower tool clamping to make sure that there is nothing in it. And it's also for learning in your new tools. So you don't need any technician to load in new tools if you need some more or whatever. So we have basically in this machine 3 tool cabinets to store your tools. We have 2 in the side and 1 in the back, and we are having a tool range or range of toolings from V6S in the lower tools up to V120. And we also have a various range of upper tools like a P5 or P4 or P7 in length of maximum 515 millimeters and a maximum height of 350 millimeters. Yes, and what we see here also, which is basically get it to the machine, are the back edges. So we have a 6-axis back edge system with some little bit bigger and thicker fingers to also make sure if you have like a little bit stronger material that you have enough space to put them against the back edges and have everything correct. What we see also in the top is the turning station of our modular tool changer to rotate tools. So we also can rotate the tools fully automatically using the robot. And now we will go outside again and see how the robot will change the tools. So, and now we had seen the tool changer in the back. We talked about some specs of the tool changer, and now we want to see that the tool changer can also change some tools, and I can relax a little bit. So I just prepared a part, and we switch now in our ByVision robot, which is the control software for our robot. And what we can see in green in the upper section of the software is the tools we want to change in now. It's a P7 and a V80. And to change, we only click on fast change and then start the tool changing process. So the robot will come now in front, and then he will wait some seconds till the tool clamping is completely open, and then he start to change the tools. So as I talked before about the optical bend guiding system, you see now where the robot will put the tools on it in the lower and also in the upper tool clamping. And yeah, in the time I've spoken to you, you see the robot will change the tools, so your operator is able to do some other jobs around the machine, and the machine will automatically bring the tools in. So tool clamping is closed, robot is parked, the job can be started now. We don't want to start the job now, we want to change some tools. So I just swap the job to another one, open it up, and now you can see on the lower position of the screen, you can see the current tool clamping, and on the upper one you see the tool station plan, which is now needed for the next job. For this we also can click on Start to start the tool changing process. What is also in the software, quite simple, is an overview about all the tools we have stored in our tool changer. We can have some information about what length we have here. We can see some details about the tools, and we are also able to change really quick the new tools into the robot. So if you need new tools, you don't need like a technician from Bystronic. You are able to do it by your own, so you just hang it in and using the laser sensor to measure in the new tools. And what you had seen also, he just kept the upper tool, the one segment for this job, so we need this for the next one, so he only built up the additional needed tools for this job and keep this segment in place. Okay, so also this job is loaded, tool clamping will be closed now, and robot will park, we can go on to bend. Okay, processing is finished, and for the third job I just take another part for us. So it's a 2mm steel part, we seen here. We go on production mode, and what you can see here is a rotated upper tool. So we are, as I talked before, we are also able to rotate upper tools. That's specially needed when you have like gooseneck tools. Then you will maybe rotate them to give your operator more safety in front of the machine. And for this, we have the turning station I talked before, and we can click on Start, so he will remove the old tools and bring in the new ones. So first we will remove everything, and then we will go to the new tools. So last but one. And now we start to bring the new tools. We're working with a V16 as a lower tool, and before the cropped one as an upper tool, and this one needs to rotate it. So we're now in the position to rotate everything. Maybe some words about the minimum tool section or minimum tool length we have. In the lower tools we have like 50 millimeters. In the upper tools we can handle also tool segments from 30 millimeters. So one more second for the lower tools. And now the robot will start picking up the tools from the tool shelf, from the back tool shelf at the moment, lift it and bring it automatically to the turning station in the top of the machine. Lay it down there, regrip, reorientate the robot, and then go and grip it from the other side. And when we see now the tool coming into tool clamping, you see it's rotated, so we don't have any issues with the operator, and the gooseneck is now in the back of the machine. So we have two more segments for this. We have a 40 millimeter upper tool segment. We are also able to rotate 550 millimeter segments, so the turning station is really big enough for this. and all tools we have in our range of tools we can handle with the modular tool changer. So one more segment to go. 275 millimeter P4. Again to the turning station. And now with the last change, I say, and I give a special thank you to company Rotauge for the time, and I go back to the studio of Gotha. Thank you very much.
Many thanks to this inside views of our customer Rotauge. So Benedikt will now tell you more about this.
Yeah, thank you, Sarah, overhand to me. Some insights to our customer Rotauge, where Eric visited this customer to show you the modular tool changer in detail. And it's a good example, this customer Rotauge from Germany, because he started his own way. He's an owner of the company, a very young owner, and he started his way also with a Bystronic product. It was an Exact Smart. And his big goal is that he wants to be an owner of a smart factory in the future. And one of these steps to the smart factory is his next step. And he bought his Expert Pro 320 ton by 4 meter last year, equipped with the modular tool changer, as you have seen in the video. And it's exactly the concept also what we offer to our customers. So we have several modules starting from bending machines in a lower price segment, but also high-end bending machines as you have seen here today. And also always components, automation components, like a modular tool changer, like a mobile bending robot, or also our big automation, which could be added to all of these press brakes. So this customer, as I said, a good example to grow together with Bystronic, to go the way with Bystronic, and nice to see that he started with an Exact Smart, go now for an Expert Pro with modular tool changer, and I think it's sure that he will end with a smart factory also from Bystronic.
I have the same opinion. I think you missed one question about Slido.
Exactly. We have one more Slido question, and we also want to ask you about your opinion. So why is automation getting interesting for you? So is it because many jobs are similar, so you have big batch sizes of parts? Is it that you want to use your machine during a night shift? Or is it that you have many different jobs with smaller batch sizes? I mentioned this point also before, that also with our new Robot Manager programming software, it also makes sense to have smaller batch sizes and run them automated, because the preparation time is not too much with the Robot Manager programming. Or is it really then the independency from employees and maybe illness of operators and not availability of operators? So please feel free to vote also here in Slido to give us your opinion, to have a better view why you are interested in getting automation. So it's really to maybe add a third shift, as we can see, so to use the machine during the night, be productive 24/7, a very important point. But it also voted for many different jobs with small batch sizes.
I just want to add something.
Yes.
What's important. Also, when you look at this here, for example, this experience center here, when you look 5 years ago, there was no automation at all in here. And then 5 years ago, we started with the automation. Bystronic moved into automation, have taken over an automation company, and now we have all bending machines with automation here. So no machine is without automation anymore. And that's what's really interesting also where we have been moving. And that's also what we see in our sales statistics now, that yeah, especially the mobile bending robot is nearly as often sold as an Expert 40 now. No? And that's really what we see, this big movement into automation. Maybe it's also one reason is something like Corona, because you can't go back in your factory always and you have automation in and then you can switch it on. Or at least maybe one guy can go and the other people can stay at home. So it's something which is changing the world at the moment, we think. No?
Exactly. And I think we have good solutions for this. And yeah, you have voted that most of you would like to use the machine during the night, so to have additional capacity for producing parts. And yeah, this is exactly yeah, what you can find also on our bending automation products. Yeah, at this stage, I want to hand over back to my colleagues Sebastian and Sarah, who will introduce our next topic for you, which is also interesting, especially in the fact of automation.
We have already seen many of Bystronic products and innovations. So, Sarah, how we can track them and how we can keep the overview about this?
Yeah, for sure. The B-Cockpit provides us with any data, with any production data for any time and for any services. So, Luis, please tell us more about this digital service.
Hello, my name is Luis, and I want to tell you something about the digital service from Bystronic. Have you asked yourself how you get live informations of your production to make quality, time and cost transparent? And you don't have to stand next to the machine. With our 30 years industry know-how, we developed an application which runs on every mobile device. iPhones, laptops, tablets, where you have the opportunity to retrieve information everywhere and 24/7. Today I want to show you the Bystronic app B-Cockpit. In the tab Factory, you have a complete overview about your complete production line, about your lasers, bending machines, and to compare availability and capacity. In cooperation with the module Plant Manager and the tab Planning, you have a status about your new orders, about the capacity of cutting, bending, and also critical orders, and if you are on time with your production. In the tab Laser, you have the status of your laser machines to predict and prevent issues and reach the highest level of availability. You have the running hours of it. You have the overall equipment effectiveness. And in the diagram staff and block, you can see if the machine is waiting for material or the machine is waiting for a user input. From the laser overview, you can break down to each single laser machine with a video stream and also the status of each machine. In the tab Banding, we also have the banding overview. We have the performance of all banding machines and the time between the different bands. From the overview, we can break down again to the single banding machines and have all diagrams. You have over 25 KPIs, and in the tab Storage, in combination with the Plant Manager, you have the value of your storage, the material rate, and the range. And all in all, you have the messenger service to have everything and directly on your mobile device.
Thank you, Luis. So during our Digital Technology Day, you guys had a chance to ask us any questions via YouTube and Slido.
Our experts, Carsten and Benedict, will of course take the time to answer as many as possible.
Okay. Yes, we are here with our last question for you, and this is about the cockpit. What's your opinion? What is the most important feature in the cockpit? The live view, of course, when you have a night shift and you would like to see what your machines are doing, it's nice you have a live view. Statistics of parts made, is this interesting? Error information or job list information? It's also maybe something what is interesting when you are traveling and you would like to know what is the next job. Especially, for example, statistics about parts which are made is sometimes interesting because you can see also statistics when you have done the same job in the day shift or in the night shift or some days before and some days later again, so you can also compare this kind of information with each other, and it's also something what some customers are looking for. But as we see here, it's interesting, most voters are going for the live view of the machine and error information. Benedict, you would like to add something?
Yes, I think live view on the machine and job list go a little bit in the same direction, because it's also possible to have a job list on our bending automation systems. So, for example, you voted before that it's very important to have an automation as an additional system for a night shift, for example, and then especially you can load different parts, and then it's for sure very interesting to see what job is running, and especially the live view, as you also here mentioned, is nice that you have the information that the machine is still keep on running. So I think by cockpit here a good solution, also combined with a camera to see the live view, to be always up to date. Also if you are at home, laying on the couch, for example, and see your systems running and producing parts for you.
It's also interesting. We have been doing something like this also in November already. We have had a number of Slido questions as well. And it's also good for us to watch at this afterwards at the results, because we are product managers. We need to look what are the market is looking for. And something like this feedback is at least a small hint for the beginning to see how the markets are reacting maybe differently. We will do the same event or similar event also with the Americas on Wednesday, and also with Northern Europe and Russia, and this is really interesting for us, your feedback, and that's also what we can learn out of this. I can just say again, we hope to see you again with us for a live web demonstration. You can book this online. We have this in the chat now, but you can find this also on the homepage. So you can always book your demonstration with us in 3 steps. You just choose your product and the date, and then you send the request, and then you can be with us in your live demonstration. This is nearly it for us. So we are really happy if you follow us on Instagram and Facebook. Many of you do it already, and you are really welcome to do this. And with this, we are at the end. Now it's 0:30. No? Oh, it's around 1 o'clock already, so we are a little bit later. From our side, we say bye-bye, and we hand back to Sarah and Sebastian for the last time.
Goodbye. Thank you.
Dear ladies and gentlemen, we are now at the end of our Digital Technology Day.
We had a lot of fun, and thank every one of you for joining in.
So for more detailed information and more features about our products, feel free to book your individual demo right on time.
Thanks to our entire team behind the scenes, thanks to our speakers and our experts, and of course, thanks to you guys for tuning in.
So I hope you all enjoyed our Digital Technology Days. So see you next time.
Bye.